Hello everybody. Today's topic, mitochondria. As you can imagine, the amount of messages I get are astronomical, and many people struggle to understand the link between fluoroquinolones and mitochondrial damage. So with that being said, here we go. Mitochondria, often called the powerhouses of the cell, are organelles that break down food to create usable energy for cells in the form of adenosine triphosphate, or ATP, which is the main energy-carrying molecule in all living cells. ATP supplies the energy needed for cellular processes like muscle contraction, nerve impulse propagation, and synthesizing new molecules. Mitochondria are very tiny and float around in your cell, and they basically burn oxygen and glucose, and that's how your cell generates energy and releases it to power these essential functions. You are 10% by weight mitochondria, so that's not a small number. It's a significant part of our bodies. Think about how much weight we lose when we're floxed. That means we lose a significant amount of mitochondria too. The number of mitochondria in a cell varies significantly depending on the cell's energy needs, ranging from 0 to thousands, and can take up to as much as 25% of the cell volume. The research is surprisingly inconsistent about exactly how much ATP a cell needs, but some of the research I found suggests that the average cell uses 10 billion ATP a day. And this is no easy feat because each ATP needs to be recycled 1,000 times per day, and this is because the body cannot store ATP, so the mitochondria must function consistently all the time. And because the brain uses 70% of ATP, this helps explains the strong correlation between mitochondrial dysfunction and neurodegeneration. Fun fact, while chromosomal or nuclear DNA is provided by both parents, mitochondrial DNA is provided by the mother only. Now, mitochondria meet fluoroquinolones. Fluoroquinolones are a class of synthetic antibiotics approved and used to treat and prevent certain bacterial infections. Their potency allows the fluoroquinolone to cross the blood-brain barrier, causing mitochondria damage and allowing it to survive in the cell for a long time, contributing to chronic long-term adverse reactions. This is called fluoroquinolone toxicity, also known as being floxed, which is mitochondria damage at its core. People often ask me, what about mitochondria turnover? Why doesn't our mitochondria get fixed then, or fix itself? What is mitochondrial turnover, you ask? It happens approximately every 3 months, and it is the process of replacing old or damaged mitochondria with new ones to maintain a healthy and functional population within a cell. It involves two processes. 1, mitophagy, the selective degradation of defective mitochondria, and 2, mitochondrial biogenesis, which is the creation of new mitochondria. Think of it this way. Each person's mitochondria is built from a template specific to them. This template is what is used during mitochondria turnover. The fluoroquinolone antibiotic scrambles the DNA, which in turn screws up your template. Now, all of your genetic code running the process for mitochondria turnover doesn't work correctly anymore. Another way to think of it is this. Think about car manufacturers that have a template for each kind of car they make. This template cranks out newly built cars that are perfect. Now, what will happen if that template gets messed up? The car has no wheels, the steering wheel is on the roof, whatever. I think you get my point. So without a properly working template, improper turnover can lead to a buildup of faulty mitochondria and dysfunction impacting processes like energy production and potentially leading to cell death. This is where we are when we are floxed, and this is why we get sicker or stay sick long after we take the fluoroquinolone antibiotic and it is perceived incorrectly to be no longer in our body. And there can be things that people can do to help their mitochondria, but the point is that template is what really needs to get fixed, or else you're just going to continue to be making faulty mitochondria. Now, what's the deal with my legs after getting floxed? Why are they often the first body part to have issues? Do you know how many times I ask this question myself and how many times this question has been asked to me? Well, lately I was talking with a physicist, and this is what I was told. Because your mitochondria is damaged from the fluoroquinolone, the hypothesis is that the body is intentionally removing skeletal muscle from the legs and the arms in order to conserve the mitochondria. All available mitochondria go to the heart and the brain first because they are mission critical. All species have a pre-programmed system that manages the decline of the mitochondrial DNA. And that's what's happening here. Outside of being floxed, look at an elderly person. As an example, someone that's 80 and maybe has a sharp mind, but they can't move around or walk that well anymore. This is because as our mitochondria ages or becomes damaged, we give up leg strength and our legs become much weaker because we're not sending mitochondria to the legs. Instead, we're sending them to the heart and the brain in order to keep us alive longer. Same thing applies when you're floxed. And for those that ask, in theory, if you want to exercise and try to maintain that energy in your muscle tissue, then why would the body not let you do that? Well, that's because there is not enough mitochondria to service that muscle. Your body knows you should have big leg muscles, but your mitochondria does not produce enough energy to those leg muscles to maintain themselves, and so you get all this muscular and tendon damage, which we know all too well. Some theory that the body is seeking to keep aligned with the number of mitochondria with the amount of muscle that it's supporting, because we're programmed as the human species to live longer. So one could make the assumption that if you fix mitochondria damage, leg strength may possibly be restored. Stay tuned for the next topic of mitochondria transplants. And finally, this video is based on my experience and research, and it is for informational and educational purposes only. I am not a doctor, and I am not here to treat, diagnose, cure, or prevent any illness or disorder. Please work with your healthcare provider to do so. Hope this explained a little bit more the link between mitochondrial damage and fluoroquinolone toxicity. More to come. Thanks, everybody.